Okay, these are the notes for Monday, August 24th. It starts chapter 2. You do not have to write this word down because it's the bold yellow, so that means it's a vocabulary word, and you will get it when you do your vocabulary. So you do not have to take this down in your notes. It's just a definition of scientific method, but I will show you a visual.
Most scientists follow these 7 basic steps of the scientific method. First, scientists make observations. For example, paleontologists observe fossilized dinosaur remains in order to learn about dinosaurs that once roamed the earth. A scientist's observations often lead to questions. Upon discovering a set of fossilized dinosaur bones, a paleontologist would likely ask, what kind of dinosaur do these bones come from? A scientist often investigates a question by forming a hypothesis. The paleontologist in this example hypothesized that the bones he observed come from a type of dinosaur that had not yet been discovered. Scientists test hypotheses by gathering data that can help determine whether the hypotheses are valid or not. A test to support the hypothesis that a new dinosaur has been discovered might involve measuring many different parts of the newly discovered bones. Then these measurements can be compared with those of bones from known dinosaur. Once scientists finish their tests, they must analyze the results. An analysis of the dinosaur bone measurements and the comparisons might show that the new dinosaur bones are either too large or shaped too differently to have belonged to any of the comparison dinosaurs that have already been discovered. Or, the test might show that a dinosaur matching the new bones had already been discovered. Finally, scientists must conclude whether the results of their tests supported the hypothesis. Let's suppose that the dinosaur bone measurement tests led to the conclusion that a new dinosaur species has been discovered. Upon completing an investigation, scientists communicate their results. Scientists often present their findings in speeches, journal articles, and books.
Okay, you will need to write down the definition between qualitative and quantitative data. Remember that qualitative data is descriptive, so you're describing whatever you're looking at, and quantitative data is numerical. You must be able to measure it somehow. Mass, for example, would be quantitative data. An example of qualitative data would be color. If you describe how big something is or how it feels, that's all qualitative. Quantitative is numerical. Don't worry about writing down system. It is a vocabulary word. You need it, but you will write it with your vocabulary.
Qualitative data describes the qualities of an object. For example, these bananas are yellow and have a smooth skin. They are firm to the touch but bruise if much pressure is applied. Qualitative data may be subjective. In describing the taste of the bananas, one person may categorize them as strongly marked by isoamyl acetate, another as having a mild flavor reminiscent of apples or peaches, while yet a third might find them sweet and creamy with a very bland flavor. Quantitative data measures properties. For example, this banana is 16 centimeters long and has a mass of 112 grams. Both of these pieces of data are objective. If another person repeated the measurement with the same banana, the results should be the same.
Okay, again, you don't have to write the definition for hypothesis. It is a vocabulary word, but just remember that is a testable statement.
A hypothesis is a theory or explanation that is based on observations and that can be tested. Two engineers named James Sarnowski and Michael Triantafilou had a question. How could they build a better boat propulsion system? A propulsion system is what makes a boat move. Most boats are driven by propellers. Sarnowski observed penguins swimming at the New England Aquarium. His observations led to the hypothesis that a boat propulsion system that mimics the way a penguin swims will be more efficient than propulsion systems that use propellers. The engineers built a boat called Proteus with flipper-like paddles that moved out and then in, much as a penguin uses its flippers underwater. Their tests proved that their hypothesis was correct. Proteus is 17% more efficient than a propeller-driven boat.
Okay, so a big part about the scientific process is when you're setting up an experiment is that you have to have controls, and yes, you will want to write the definition for that down. Controls are conditions that have to remain constant. You have to have something to compare what you're testing to, okay? So you have to have something that is not changing the whole time so you can compare the things that you're changing to it. Okay, variables are any experimental conditions that change. So you're going to have usually an independent and dependent variable that you will be changing. You compare those variables to the controls. So make sure you write down those definitions. Okay, also you're going to want to write down repetition and replication. So it is the expectation that an experiment will give the same result when it's performed under those same conditions. And then on replication, it has to be reproducible by other scientists if they follow your procedure exactly. So you will need to write down those definitions. Okay, so just real quick, theory is one of your vocab words, so you don't need to write that down, but it's just a broad generalization. Underneath, it gives you a few examples of theories, but usually they cover a wider area than hypotheses. But again, you already have the definition for theory in your vocabulary. Okay, also, we already have model. It's just a vocab word, so you can check out the definition for that on your own. This is just a scientific method. It's a visual for it. Definitely helpful to look at that. You probably don't really need to write it down, but just remember how that thing flows.